Hello again, this is part 5 in this series on Domino static site generation. In this portion, we'll talk about using Next.js to create an app where we can do static site generation with content coming out of a Domino database using the Domino REST APIs. So, as background to create an app, here's the simple process of creating a Next app. You do npx create next app at latest. Of course, we'll use the latest version. So when this was at creation time, the latest was 1404. And answering the questions after giving it a project name. Do you want TypeScript? Yes. Do you want ESLint? Yes. Tailwind? No, thank you. Do you want to use source directory underneath your project? Yes. Do you want to use the app router? Now the app router replaces the prior pages router that came with Next.js prior to version 13. Pages router still does exist. And in fact, the app router and the pages router can coexist in the same project. Some routes can be served by the app router and others by the pages router. So if you're used to the pages folder in Next.js, that's the pages router. The new app router is the app folder where everything in there automatically becomes a route, which I'll explain further. The import alias is, we said yes to configure it, but actually left it as @/star. And so the app was created. The next thing that we did is enable TurboPack. If TurboPack works for you, you'll want to turn it on because it's much faster. TurboPack is based on SWC, which is the Rust-based transpiler and bundler. This replaces Babel and Webpack. So for quite some time, common tooling was a combination of Babel and Webpack. Babel's a transpiler. So Babel has an add-in that can transpile JSX, which is React's presentation syntax. It looks like HTML, but it's actually JavaScript based. So it can transpile JSX into JavaScript. It also transpiles to lower ECMA script or ES script versions that could be understood by lowest common denominator browsers. And then Webpack is the bundler. So it merges code, so you don't have 100 HTTP requests. It merges everything into bundles and minifies. So that's been replaced with TurboPack, and it is quite a bit faster. In Next 13, turning TurboPack on didn't work for us. It was breaking a bunch of stuff in our apps because it was a work in process and they hadn't implemented everything in TurboPack yet, all the features. In version 14, we were able to get it to work. We had to make a few changes to our project to make it work, but no showstoppers, so we got it working. And it is noticeably faster than not turning it on. Times shown are with an Azure virtual machine with 2 vCPUs, 8 gigs. It's a D280S image in case you're interested. So let's explain the way file-based routing works with the app router. So this is a picture, not at prod time, but in your development workspace. So you got the source folder. Under source, you have an app folder, which is where everything for the app router lives. Every page.tsx or page.jsx that you put in a path underneath the app folder automatically becomes a route. So right as an immediate child of app, this would be the home page. So this is HTTP your host / underneath about us, page TSX, that becomes /about us as a route. Ditto with products becomes /products. So wherever you put the page TSX, its relative path to app becomes part of the URL. And layouts are kind of interesting. We're not going to deep dive in them in this series, but they're a feature of App Router that allows you to define common layouts that are used by a bunch of different pages. And they can be hierarchical. If a child folder doesn't have its own layout TSX, it'll use the parent folder's layout TSX. And there's some neat features with those. So those are a nice thing in version 13 and beyond since the introduction of the App Router. So now we'll do a demo of SSG. And one thing that we want to talk about is dynamic segments. So as background, it's not just putting stuff under a folder name. You can actually take a folder name and wrap it in square brackets. Now, if you do that, then that can become a parameter. So it becomes part of the params prop to your page. So to the layout and the route as well, but the page in particular. So we're looking at pages. So you can see here the blog. A blog could have the following route /app/blog slug. Slug is what is going to get passed in as the parameter. And so you can make friendly URLs where the slug becomes part of the URL. It doesn't have to be called slug. It can be called whatever you want. So whatever you name that folder is what your dynamic segment will be. And we'll look into data fetching separately. So to start with, let's do a demo. Here we are. So I'm in the right folder here. So I'll just run the app. While I'm running that app, let's take a look. So we've got underneath app, we have a products folder. Underneath products, these are dynamic segments. So category code is in square brackets. Underneath the category code, we have another folder in square brackets called prod code. Let me show you why. This app is up and running. On first load at dev time, it takes a minute to compile the route. It's going to compile the page component. That's a dev time thing. It's a lot faster once it's done. Okay, so if I go to the products page and take a look, there are 4 categories here. So there's batteries, cables, charge controllers, and solar panels. We want friendly URLs with nice slugs or nice segments in the URL. So products, that's just the name of the folder product. So that's just a hard-coded folder name. But if I click on batteries, you'll notice my URL is /product/batteries, and then here's all the batteries. And if I click on one of the batteries, like say BAT D12100, let me click on that. Friendly URL, products, batteries, BAT D12100, where neither that nor that are hard-coded. That's coming straight out of the data in the remote database, in the products database that I showed you in the prior video. So let me show you how that's working. Back to the project. Category code. So products has its own page TSX, and that had the component to show you the product categories. It dynamically goes and gets those product categories by calling the remote Domino REST API and finding them. But under category code, let's take a look at that. So here's the page component. As its parameters, it's going to take the category code. Oh, sorry, forgive me. I am in prod code. I meant to be in this one. They work similarly, but first to look at category code, the page TSX and category code. It has a page component. It has a params object that looks like this. So the params object has a category code, which is a string. So when we go /batteries, it's grabbing this as category code. And then what it does is get products and category based on that category code. And that module is calling the Domino REST API. So it's calling a remote REST API on a Domino server, getting back all the products in that category. And then it passes those. So this is an array of type product where this is TypeScript. So I've defined a product type. We're passing that TypeScript array to a custom product list component, which is what you are seeing right here. I don't need to dissect all the React components. You can imagine what it might look like. Pretty straightforward, right? And so for each one, let's take a look at the component for the individual product. So that is found here. So the first one I accidentally opened. Underneath prod code, page.tsx. This time the page component takes a product code and a category code. And this time we're going to call get product from code. These are just utility functions that we wrote in a TypeScript module. And again, it's using the REST API to make a remote call to the Domino server. So that allows us to handle a call to get BAT D12080, for example. So if you wanted to run with server-side rendering, that's what you're witnessing right now. This is running on my developer workstation. It's a cloud virtual machine. It's being server-side rendered. So what's noteworthy here is if I look at DevTools and I do a shift reload here, there's the document request, and that document request will have a fully populated DOM. So this is what came back from the server. It's all the markup. It's not an empty div like in the client-side React app. So it was server-side rendered and sent back completely server-side rendered to the client. So that's different than React client apps. But to take it a step further, if we want to do static site generation, then it needs to execute this page function for every possible. So in our example, we're going to talk about static pages for products. For every possible product, it needs to generate a page. And it does that by executing the same page component that you would do it if it was server-side rendered, and it gets passed in the parameters for the product code and the category code. The operative question is, well, how does it know which pages it must generate static HTML files for? Well, the way it does is they allow you to implement generate static params. In generate static params, however you do it, they don't care. They want you to return an array. Each member of that array should be like your params object gets passed to your page component. So you can see where I'm going with this. What we need to do is get all the possible products, and for each one, return an object that looks like this. So we call get product data. That returns an array of products. On that array, we're going to call map, which will return a different array where each member of that array looks like this. So we take the member of the original array, the product, and return a new object that's got a prod code and a category code, which is what our page component needs. And then once that's run, for each member of this new array, it'll execute the page component and spit out an HTML file. So take a quick look at the folder hierarchy. Underneath our app, we've got products in square brackets, category code, and prod code. This is different than what the production build will look like. Here's what I've already run a build here. The dist folder is where your build output goes to. And if you take a look at it, you'll note that under products, we no longer have those folders with square brackets. Now we've got batteries, cables, charge controllers, and solar panels. Why? Because that's the data that it found. And if I expand batteries, there's a folder for each of the product codes. So it's generated a page statically for a product code. So bat D12080 has an index.html. Every one of these folders has an index.html in it. And that's important because pretty much every web server will treat that as a default welcome page. So there's really not any configuration you have to do other than to take the contents of the dist folder and deploy that to a web server or perhaps put some of it on a CDN. So it's pretty slick. Going back to the presentation. The data fetching is something we'll take a quick look at. We talked about static site generation, and again, the dynamic segments plus the static site generation is what make that possible. So to recap what we did, this is a picture of what it would look like at runtime if it was server-side rendered. So your browser makes a request to the web server. The web server is going to proxy that request to a backend app. In this case, it's a Next.js app with a node interpreter. It receives that request, and the page component that corresponds to that request says, oh, I need to reach out to the remote API. So it's going to call the Domino REST APIs, and it's going to get back /product/batteries bat D12080, for example. Oops, forgive me. Or we also have other calls where we expose a Domino view and gives us a list of all products. So pretty slick. The Domino REST APIs responds with JSON data. That JSON data is received by the page component, but this time it does server-side rendering. And instead of sending back JSON to the client like a REST API would, it renders HTML on the client and sends a fully hydrated DOM to the browser. And so what the browser receives is, again, HTML. As I mentioned, the static site generation goes a step further, and instead of just at runtime grabbing it and returning it dynamically, it statically generates a page for each possible route. So at runtime, we do not need that node interpreter. You can put all the contents on the web server. If you had stuff that has to be dynamic, so if you've got an app that parts of it need to be dynamic, you can do that. So for example, say on the product, we want to say there's this many in stock, or if you're logged in, what is your price? Those are things that could be done with a client-side data fetching approach. So the page loads, the page was statically site generated, but the JavaScript bundle says, okay, at runtime from the browser to the server where there's a REST API, a backend REST API, give me the inventory stock level for this product, or give me the price for this product. So you don't lose the ability to do things dynamically, but for SEO capabilities, you can't beat static site generation. So hope that's helpful. And I think it's a really neat use of the Domino REST APIs that you might not have thought of. Thanks for watching.